An introduction to the rectangular coordinate system. Basically, what the rectangular coordinate system is it's a system consisting of two number lines. You've all worked with the number line before, so that's where I'm going to start. Let's draw a horizontal number line, and I'll just let that be the point 0. On the rectangular coordinate system, we're going to call the horizontal number line the x-axis. Okay? Now what we're going to also need is a vertical number line. And we're going to call that the y-axis. Now let's go ahead and put some tick marks on our number lines. There may be 1, 2, 3, and so on. We could certainly go in the negative direction as well. And I'll label going up is going to be positive values, so we'll label that as 1, 2, 3, etc. And those would be negative values. Now, this point right here is called the origin. That's where our rectangular coordinate system originates. Okay? Now notice our rectangular system is divided into 4 pieces. These pieces are called quadrants. And we can label the quadrants as follows. We always label in a counterclockwise fashion, starting with this one. That is known as quadrant 1. We use Roman numerals to label the quadrants. This is quadrant 2. This one down here is quadrant 3. And this one is quadrant 4. Now, what I want to do is first talk about plotting points. So let me just give you an example. It says, plot the following points on a rectangular coordinate system. Well, I'm going to need a rectangular coordinate system, so I'll quickly draw it. There it is. I'll put arrows to represent that the numbers can go infinitely in each direction. Now let's look at this point. Now that looks an awful lot like an interval, the interval between 1 and 3. In mathematics, a lot of times we're going to encounter things that look the same, but just like when you're reading a book, you know, certain words look the same, but they have different meaning. Same in mathematics. This looks like an interval, but it's really a point. And what do I mean by point? Remember, this is the x-axis. This is the y-axis. These are called ordered pairs, and I'll write that down. Ordered pairs. It's a pair of number, and they're ordered. This first component represents the x coordinate, or the x value. The second component represents the y. So if I want to represent this point somewhere on my coordinate system, I simply go over in the x direction 1 unit, and I go up 3 units. And there's the point 1, 3. Similar, if I want to plot the point -1, 2, that means I need to go to the left 1 on the x, and I need to go up 2 on the y. So there's the point -1, 2. Let's do the next two. The point -1, 3. I'll go over -1, and I'll go down 3. You probably have the hang of it by now, but I'll go ahead and plot the last one. Let's plot the point 1, -4. So let's go to the right 1 on the x, and then we'll go down 4 on the y. And that's all there is to plotting points. It's fairly straightforward. Let's look at a different example. Okay, it says, show that the ordered pair is a solution of this equation. Now this is known as a linear equation, and if we want to remember, a linear equation is pretty easy to figure out if it's linear or not by simply looking at the variables. My variables both have a power of 1, so this is a linear equation. We'll actually graph these in subsequent lectures, but let's try to figure out what this problem is asking us. It says, show that this ordered pair is a solution of this equation. Now remember, the 3 represents an x-coordinate, and the -2 represents a y-coordinate. So what it's really asking us is, let's plug the 3 in for x, let's plug the -2 in for y, and let's see if this equation is satisfied. Let's see if it actually equals 1. So wherever I see an x, I'm going to plug in the x-coordinate, which is 3. Wherever I see the y, I'm going to plug a -2, and we'll see if that equals 1. 3 times 3 is 9. 4 times a -2 is a -8. And 9 plus a -8 is in fact 1. So this is certainly a solution. Now let's take a look at what we've actually done. We have said that this is a linear equation. So its graph must be a line, and we'll talk about graphing these later. But we know one point on this graph must be the point 3, -2. Another point that is on this line, I'll just tell you, another point is the point 0 and a fourth. We could probably verify that pretty quickly. If I plug a 0 in for x and a 1/4 in for y, notice when I plug the 0 in here, I'm going to get 0. 1/4 times a 4 is 1, and that certainly is satisfied. So here's another ordered pair that's on this linear equation. I'm going to attempt to plot that point as well. Well, the point 0 and 1/4 is over 0, so I don't go anywhere on the x, and up a fourth, so just a little bit. Now if I extend my line infinitely in each direction, I see that this is the equation. 3x plus 4y equals 1. Now notice, here was our first point, 3, -2. That point is on this line. It satisfies the equation. Also the point 0, 1/4 was on that equation because that also satisfied our equation. There's actually infinitely many ordered pairs on this line. Okay? What we're going to do in later lectures is take a look at these linear equations in more depth, and we'll graph them, we'll talk about them more. So don't worry if this is a little confusing at this point, because it probably is a little bit. But if you review the next lecture on graphing linear equations, you'll get a better feel for it. So let's recap. This is called the rectangular coordinate system. To represent a point, we need an x value and a y value. The x value represents the horizontal direction that we need to go. The y value represents the vertical direction. And again, we're going to talk about graphing linear equations in more detail in upcoming lectures.